Dear respected judges, my research topic is on developing bioabsorbent from bay leaf for the treatment of wastewater contaminated with heavy metal, copper, cadmium, plumber, and zinc. The objective of the study is to prepare bioabsorbent from the bay leaf for the characterization of physical and chemical properties, to assess the removal efficiency for heavy metal of choice in both synthetic wastewater and wastewater. The study the absorption capacity of the bioabsorbent at different dosage, to evaluate the reusability of the bioabsorbent over multiple cycles. The novelty of the study is the Aegle marmelos tree itself. There are limited study of this species in environmental remediation in Malaysia. However, there are some notable researchers from other regions, especially in India. The next novelty reported by Sunny et al., Bebar Merchong, slightly polluted, have no wastewater treatment publication yet. Research benefit of this study is cost-effective, inexpensive compared to synthetic materials used in other techniques, sustainability derived from renewable biodegradable materials, highly selective, especially to the lead metal, and no toxic byproduct, unlike some chemical treatment. The research process is the wastewater sample collection, bay leaf collection, and bioabsorbent preparation, continued with the absorption experiment in the laboratory under optimized condition. An analytical method, AAS, atomic absorption spectroscopy, Fourier transform infrared, FTIR, and SEM scanning electron microscope. Continued with data analysis, absorption isotope, and kinetic model, namely Langmuir and Freundlich, pseudo first order and pseudo second order. Lastly, the regeneration and reabsorption of the bioabsorbent. The process flow of the experiment is bay leaf is collected and washed with deionized water and continued wash with hot deionized water, then dried in oven for 24 hours at 70 degrees Celsius. The leaf is then crushed, sieved through 180 micrometers, stored in specimen bottle. At the same time, metal ion concentration is prepared and incorporated with the bay leaf powder and shaked in the incubator shaker for 3 hours at 200 rpm with 30 degrees Celsius. After the absorption experiment completed, the metal-loaded bay leaf were filtered, washed, and dried. The experiment is repeated with other metal of choice, and the liquid sample of the absorbed chemical before and after is sent for the AS, FTIR, and SEM for the before-after characterization and also metal ion concentration determination. The whole process is repeated with wastewater sample, Juru, Lingi, and Merchong. The factors affecting the absorptions are pH, contact time, initial contaminant concentration, temperature, absorbent dose, and particle size of the absorbent will be studied in this research. So based on the previous publication, there are 70% removal efficiency for the metal of choice in different publication, and this optimized condition will be used as a reference for my studies. In my studies, I'll be concentrating on absorption dosage for the synthetic wastewater, cadmium, copper, plumber, and zinc, and also for the wastewater treatment, Juru, Lingi, and Merchong. I'll be just focusing on the absorption dosage. And lastly, to conclude, contribution to the Sustainable Development Goals, there are 3: good health and well-being, clean water sanitization, responsible consumption and production, and lastly, climate action.